Okay, thank you, sir. We want to create a little subprogram here. So let's just right-click on your folder and create a new Python file. And let's call it CH9 print stars. And last week you guys were printing the border around someone's name. So we'll do something that's a little bit similar. So whenever we work with Python, oops, try to get my stuff lined up here. Remember, I always put script here because Python is a scripted programming language. That means that it's being interpreted as it's being run every single time it's run. So we never save anywhere a version of this code that's in any other version. Where if I were running like a C#, C++, that code would be compiled to more of a machine language to be run, so it would be saved in different versions. With Python, we're executing our script every time with the interpreter. So when we have a function, the function must be defined before it can be called. So if I'm working with a C# programming language, that's not a rule. It doesn't matter where that function's defined anywhere in my program. I can call it over here and have it be defined over here. With Python, as we read through our Python file, that function must be defined before we get to code that tries to call it. That makes sense. So whenever we declare a function in Python, we're going to use the def keyword, and that defines a function. So it's pretty easy and straightforward. The function that I want to create for this one is going to be print stars. And then after the function name, we're going to do a set of parentheses. And within our parentheses, we would put our parameters. So let's say that for our number of stars, we're going to allow people to pass us a number of how many stars they want printed. So let's say we're going to expect that num as a parameter. Then after our parameters, we're going to close that def statement with a colon, which means to Python, the def statement has a body. Everything that's indented now under this def statement is part of this function, part of this subprogram. So for this one, we would like to have a string maybe that just returns this number of stars. So I could say that I want to declare a variable. I'll call it return string, and I'll set it equal to just an empty string. Then I'm going to set return string equal to a star. How did you guys do that times num like that? Is that how Python does it? No other programming language is going to let you do that. So you better enjoy it while Python lets you get away with it. Now I would like to go to a new line in output after these stars. So I'm going to add that \n control character to my return string. Now if I look, PyCharm is giving me kind of a squiggly line. It's saying, I don't know what you're doing there. Well, we're going to watch that and see, because It says no new line at end of file. Well, I'm putting one, so we're going to see if that causes us trouble. But we know to watch it because we are getting a little warning from PyCharm, but we're also getting it here from our return string. Variable and function should be lowercase. That's what it's griping at me about. Okay, so now with this line of code, my return string variable should contain however many stars their number was that they're asking for, plus that new line character. Okay, so I'm going to return it now. I'm going to say return string, and that's going to send that back to the caller of our function. Now, because I have that statement return, PyCharm knows I'm done with my function. And when I pressed enter, it went back out and dedented. Now I want to call my function. So I'm going to put a line of code in, print stars, just name my function, that's how I call it. And I'm going to say I want 10 stars. So let's run this. Well, it worked, but I need to do something with those stars, huh? So let's print them. I'm going to put print and wrap our print stars call within a print function so that we can print that output. Ah, there we go. Now I've got my 10 stars being printed out. Now, in our hierarchy chart in that data flow diagram, they always show that main module being the one that kicks everything off. And with our code so far, we've just been putting our Python code in. We haven't been worried about these modules and functions. We don't have a main module. Let's create one. I'm going to make this print statement be in the main module. So now I have a nice organized program where I have a main module that calls my print stars module or function. Let's run it. Again, I'm back to nothing happening. In Python again, I'm going to have to run this main module. So even though as a programmer, we know that we usually start a program with a main module, we still have to tell Python to run it. Now if I run again, I should see my stars as output again. So let's make some notes in this code and then let's update our quick reference. So this one is really nice and straightforward. We see a lot of things here in this little sample. So first of all, our def statement, it defines a function. The function name is after the def statement, def keyword. Then we have a parameter list, and that is within our parentheses. The parameter list, I'm going to indent there a little bit, it defines all our needed inputs. So whatever inputs our function needs, we have in those parentheses. If we needed 57 things, as a beginning programmer, you would say, I don't want to write that function because I don't want 57 parameters, that's too much, I'm just going to put it in my code. But as you get to be a better programmer, you would say, oh, I need to declare that function because with those 57 parameters, I might need to call it in 100 different places. So I would just list each of them with a comma. Now, they have to be in the same order. Right here, we only have one parameter, so we don't have to worry about what order it's in. Okay, so let's talk about then calling our function down here. Our function is named print stars, right? So just by putting its name in our code, its name becomes a Python keyword in our program, right? Python knows what that means. So print stars is now a keyword for this program or script. If I wrote another one, it would know nothing about print stars. But anywhere in this Python script that I'm writing, print stars is now a keyword that I can use, and it recognizes it, and it says, oh, print stars is a function name that I need to call. Now, after the name of our function, when we're calling it, we specify the arguments to fill in the parameters. So I guess you could almost think of it as kind of like a bracket for March Madness, because you have all those empty slots. Those are kind of all of your parameters, all of the different teams that you could pick. And then when you actually write something in, that's supplying an argument to that parameter. Now there's a value there that's filled out that whole thing so that you have a plan. So that's basically what we're doing here, is we're saying this argument, this number 10, should be used where this parameter is needed. So what if I wanted to call our print stars more than once, and I wanted to print out like a whole box? Could I do that? Right now in my print stars call, I just have it stuck like here in my main. Could I do a for loop? Would that do it? Run it and see. Now you should get 10 rows of 10 stars. So that's why I mentioned we'll be doing a lot of looping practice no matter what we do, because we always get an extra chance. So we're just saying we just want to run it 10 times. Oh, mad at me. Let's see what's it mad. Int object is not iterable. Should I do, oh, should I have range? Oh, I was trying to make it too easy, huh? Getting rid of even that range keyword. Now it looks like my new line character is making it jump too. I'm going to take that out and see what happens. And run it again. Oh, now they're a little closer together. They're still pretty dense, huh? Now, since I'm using this fancy thing, how could I add a space between each star? Just that easy?
Well, I would hope so.
Let's try it. Oh, that looks better. That looks a little bit boxier. They were so close together that they weren't looking very good. Very good. Okay, so now we see that with our functions, we have the ability to take some code, some logically separate code that belongs on its own, and put it on its own. And then we can call it over and over and over again if we want to. I'm going to save that one. Questions? Is it working? Now, what if I didn't want this variable return string. Do I have to have it? Could I just say, let me try something here. Do you see anything in PyCharm that would let me comment out these lines of code? Do I have to do it myself? How annoying. Yes, sir? Their way? I don't see anything. So I'm going to try commenting these two out. Whoops. Yeah. So as programmers, we like to comment things out because especially you'll see if you've spent hours creating code that then you decide you don't need, you usually like to comment it out because you're kind of attached to it and you think you might need it again someday. And sometimes you do. So here now I've just said return this value and I got rid of that variable completely. Does that work? Can I do that? Sure. Sometimes for us, when we're first starting out, though, it's easier to realize, you know, that we could create a variable and put all that stuff in it and then return it. So that's another reason I wanted to comment it out, because I want you to see that those are both possibilities. All right, so trying things, that's the key. That's what we want. All right, so back to our beautiful SalePrice program. Whenever we looked at it, we knew that we could calculate the price based on the old price of the product, what the discount percent was, and then we could calculate the new price. In this output method, we're going to need all of those things to output it. They want you to really be aware here that things are going to be passed in order. So when I call a program here and I say I'm going to be passing these 3 data items, they're going to be passed in that same order in the parameter list of the definition of the module. So if I get them out of order, it'll be wrong. So for example, when I call the output program, subprogram, I'm going to be passing the original price, discount rate, and sale price in that order. The output results function definition then is going to expect those parameters to be passed in that same order. They don't have to be called the same thing. Notice they can be completely different names, but they just have to be in the same order. This just I love that they have an animation on there. Oh, look at him. He's so cute. Yay. All right, so this is an example. Here we have a subprogram called exam. It's in pseudocode, so it's good for you to look at because it's not in Python. So we have 2 different calls of this exam subprogram. Now our exam subprogram says it requires 2 parameters. One is the time and one is the room number of the exam. Then it's going to write out this message. Your history final will be at time o'clock in room number room. So in this execution, we passed in a 9 for the time and a 3 for the room. So our output message is, it'll be at 9 o'clock in room number 3. That looks right. Now here, when we called the exam, we have those arguments swapped. So we're saying that the time is 3 and the room number is 9. So that's going to have a really dramatic impact on our output. Now it says it's going to be at 3 o'clock in room number 9. We don't know which one is right, but one of them is real wrong, right? So it makes a big difference what order those arguments are passed in as parameters. Whenever we're passing data back and forth, arguments and parameters, why do we want to do it? Well, whenever we're trying to create modular programs, which is what our goal is, we're going to need to be able to have data available to some of these subprograms. Whenever we're looking at subprograms, again, we don't have to worry about naming our variables. We can name them whatever we want in our subprograms, but we have to know what data we're using. We like to use subprograms because it makes it easier for multiple programmers to work together on a program. So if we decide we're going to split this program up into these different functions, I can have this person work on this function, and this person work on this function, and this person work on this function. They shouldn't really have to communicate too much with each other, just getting their function to work and test. And then we can put them all together to do a final test and make sure that everything works properly together the way it should. Now, in some programming languages, when we declare our subprograms, our parameters have to specify what their data type is. So this is an example of that. This is an example of something like we would see in a C language or a Java language. We can't just say variable 1, comma, variable 2, comma, variable 3. We have to say variable 1 is a string, variable 2 is an integer, variable 3 is a float. Now, we don't have to do that with Python. Python will figure out what the data type is, but be aware you might have to do that with some of your other programming languages. So it'll be a little bit of a change. So here's an example. Let's look at our SalePrice program. I think we can do that. Yay. All right, our SalePrice program. I'm going to bring up what we already have done and see where we've left off with it. But we won't refer to this old version, so it won't matter what you have. But I'll show it to you and we can all look at it. So our SalePrice program was one that we did a little bit more than a month ago, right? It's been a little while. So we've been doing a lot of looping. Our SalePrice program didn't really involve much looping, so it's just been sitting on hold. And here it's so exciting. Yeah. Okay, so we declared some variables. We prompted for input, what item it was and what the original price and discount percent were. And then we did a couple of calculations. And then we printed out the sale price and the tax for debugging, but our good output was a nice output message. So we're going to redo this program now in a modular approach so that we can set things up in a good modularized way. So let me see if I can get this one over here where I can see it, but out of your way. And let's create a new Python file. And I'm going to call it Chapter 9 Sale Price Program Python. Now I want some comments again. Okay, so we're going to create a modular version of the sale price program. And looking at that PowerPoint, they had that data flow diagram for us that we can use to kind of make an outline of what this program is going to look like. And then we can fill in with our code. But it's really a good idea to design your programs first, like they did here, and say, well, we're going to have a nice welcome message and a prompt for data, do our computations, our processing, and then our output. So that's a nice model. We also have specified here what kind of data is going to be going back and forth. So this is a good model for us to use, and we can use it and, like I said, create kind of an outline. So in Python, I know that I have to create or declare my functions before I can use them. So I'm going to start out with the welcome and Then I'm going to dedent, and we're also going to have a input data. And so this will be sort of like my outline. I also want to have a compute, bless you, function. Notice I don't want to name my input data just input, because we have that Python keyword input to input our information from the console, so it could be confusing. So we'll just make ours a little bit different. And then finally, we want our output results. Now I can add some data. Our compute result is going to need some input. It's going to need the original price and the discount rate. Our output result is going to need some data. It's going to need the price, the discount rate, and the new sale price. Python is getting mad at us, or PyCharm is, about this outline because we're not putting code into our functions, but we'll make it happy here in a minute after we get our outline kind of lined out. Now, all of these modules are going to be controlled by our main. So we'll define our main module. So I know for sure my main module is going to call the welcome. Then it's probably going to call input data. It's going to call the compute. I'm going to need to add some to this, but this is going to be my basic flow. So a couple of things to really notice. When we define our function and we have the parentheses with all of our parameters specified, we follow that with a colon because we're defining it, and a body is going to come afterwards. When we're calling our function, we don't have the colon, right? Because we're not defining it at that point. We're just calling it. Okay, so what do I want in my welcome message? A welcome? I think a welcome is good. We didn't have much of a very good welcome before, so let's create one. Welcome to the SalePrice Program. Where you can find the prices of your dreams, huh? We'll put a nice line under that. Now, in our welcome, that's all we need to do. It doesn't need any input, right? It doesn't produce any output. It's not going to return anything back to the caller. That's all it does. It just has this one job of printing out this welcome message. So that is its function in a nutshell. We don't have to worry too much about anything else there. Now, our input data is a little bit different. In our input data, we have a couple of things going on. First of all, we want to find out what the item name is from our user. So we could declare our item variable is an empty string and then prompt for it. Let's say, please enter the item name, and now that'll be our item. Now next, we want to prompt for the original price. And we decided that that would be a float. I'm going to move my declaration for that up here after item. And then the third thing that we'll prompt for is the discount rate. Our discount rate is an integer. Now, I want to prompt for these other two things. So our original price, let's say we're going to, first of all, cast that as a float. And we're going to prompt for input saying, what is the original price? And then our discount rate, we want that to be converted to an integer. And we'll say, what is the discount percent? Now, as soon as I get to the end of this function, I'm in a conundrum because I have three things now, three pieces of data that I need to return to the caller. And somehow in our main method, we need to save these three pieces of data so that we can keep using them. Whenever we're working with a function like this, our variables have limited scope. That means these variables only exist while we're in our input data function. As soon as this function is done, the processor moves past it, we're not executing it anymore. These variables don't exist anymore. So somehow we have to take that data and return it back to our main. Well, it's no big deal, right? With our stars, we just did a return statement. Can we return three things? We just returned one thing with our stars. So I'm going to tell you flat out, in most programming languages, you can only return one thing. I have one function to do one purpose in life and return one thing, which means I should have one function to get the item name and return it. I should have another function to get the price. But here we've messed this all up and we've pushed these all together. Can you get on Google and see if we can return three things from a Python function? Python always breaks the rules. It says we could use all sorts of fancy things, right? This one I'm looking at. The one, I don't know where you're looking. I'm looking at Geeks for Geeks. Has anybody found anything better? I'll check Tutorials Point. They usually have good stuff. Again.
One of the ones that I saw on Google is just Python basics.
Is it good?
Yep, and it shows how you can return multiple things.
What's it say you should do?
You can just use the return function and then list them with commas.
Is there a limit? Can we do three things or just two like that? This one they're doing three. So when we return multiple items like that, we're using a tuple or a tuple, and I'm going to let you decide how you say it. It's kind of like data and data. But the tuple is basically a list, a short little set of items. And so it lets us take care of situations like this where we really don't want to make each of these inputs into a separate function. That would make our program so modular it would almost be harder to maintain, but yet we want to be able to take care of this thing of returning multiple values. So let's try it. I want to return then the item, the original price, and the discount rate. Now, this is one of those Python things again, but that means when I call my input data, I'm going to have to expect 3 things to be given to me. So I'm going to say, when you call input data, expect to have returned to you the item, the price, and the rate. And I'm going to list those 3 variable names before the equal sign. And after the equal sign, I'm going to call my function. And that's how I assign the return value from my function to a variable. Right? So I'm saying there's going to be 3 variables returned from this input data function. Save them in the item variable, the price variable, and the rate variable. Now I'd like to go ahead and declare those variables in our main, since we like to do that. So we're going to say our item is a string, our price is a float, and our rate is an integer. Our main is getting a little bigger. We like to really keep the main small. Like to have it doing as little as possible, most of our work going on in our other functions. All right, so can we test this yet? It's mad at us about this last def. Indent expected. So let's do our, I'm going to put something in here. Just put a little bit of debugging code. So in our compute function, we'll print out a statement that says we're in our compute function. And in our output results function, we'll print in output results function. That should get rid of all the errors so that we can run our program. So I'm not going to leave those print statements in, but it'll simulate what's going on for us so that we can get it to run. So right now, I've got everything in the main to call our welcome. Actually, it's going to call all of our functions. Don't forget, at the very end then, we need to actually call our main method. And that'll kick off our whole program to run. So now I'm seeing our prompt. Here's our welcome. Welcome to the SalePrice Program. Please enter the item name. What is the original price? It's $50. What is the discount percent? We'll say it's 10.
Mine's not working.
Yours what? Yours looped? Let's see some of them. He wants to show us. Grab the share. Come on, share it. Let's share with us. That'll help everybody. Well, share with us and we'll fix it.
Okay.
That'll help everybody to see your problem, if you don't mind. Yeah, join the Zoom. And then once you're joined the Zoom, you can share your screen and we can all see. Okay, so it looks like, what kind of error is he getting?
Intensive block. What is that? How do I do my screen?
Everybody should see it. Can you guys see it? So what's it telling and what's it saying is wrong? It says it expected an indented block.
After the output statement, it doesn't like the
What about that compute function? Put a line of code in there. Just put a print statement in there. Your compute function. Yeah, inside of it, we just put print in compute function. And let's see if that takes care of it. I'm still getting, mine was canceling after I entered data. Okay, so it's asking you for data now. He's cheapo.
Yeah, that's a one.
You know, we define those variables and it seems to want them like now. It wants them.
It's like, give them to me. We're going to have to do some debugging and figure out what's going on there. Yours doesn't loop? Mine doesn't work. What's yours? Yours loops like that, like his? Let me see if that was what mine was going to do. Get it. Mine is mad at...
It's because it's trying to call the compute module and the compute module doesn't have price and rate.
Ah, good debugging. So that makes sense, right? Because I told it, you're going to need these two pieces of input, but then when I call it, I'm not giving it those two pieces of input. So let's fix that. We know now that we've got our price and our rate from our input data function. So we should be able to pass it to our compute. We need price and we need rate. Now I'm going to go ahead and leave that print statement in because it could be helpful for us in debugging and seeing how things are working. So in our compute module, we just have a couple of calculations. First, we calculated, oh, let me add some variables. We have original price. No, that's our price. We've got it. Rate. Okay, we need amount saved. And that will be a float. We need our sale price, and that will be a float. And we need our tax. And that's going to be our tax amount, so it will be a float. Okay, I think that's all our variables that we're going to need for our compute module. So we'll print out a message that that's where we are, and then let's calculate our amount saved. Our amount saved is going to be our original price times our rate divided by 100 to make it into a decimal. Next, we're going to calculate our sale price. It's going to be equal to our price minus our amount saved. Our tax is going to be equal to our sale price times 0.065. Of course, we want to set that up as a variable. Finally, our new total price is going to be equal to our sale price plus our tax. And I need to declare our total price. So if we look at our data flow diagram for this module or this program, it says that our compute results needed the original price and the discount rate as input, but it's only supposed to return the sale price is output. So that's all we need to return. And I kind of think that they mean the total price. So that's what I'm going to assume, but I am having to make that assumption because it's not exactly clear. So again, when we do our calculations method, this is kind of our processing for this program. All of these variables that we declare are limited in scope. They're local to these variables. They're not global. Global variables are variables that we can access throughout our whole program. Python hates global variables. It makes it kind of hard to use them. Plus, beginning programming students, if they get to use global variables right off the bat, they get really spoiled and they hate doing things this way, which is the way they have to do them. So Python works great, so we just won't use any global variables because they're kind of discouraged. But a global variable would be one that we could get to in all of our different modules. We as programmers like local variables because that way, if I have Mike working on this function and Aaron working on this other function, they're not working on variables that are the same, right? They each have their own set of local variables for their function. They do what they want with them. We can have all that coding happen with those other people. You know, it all split up and it'll all work when we put it all together. Okay, my output results is still going to cancel. So let's do a few more things here. Whenever we use our compute function and return our total price, we can run it this way and we wouldn't have any trouble even though our main doesn't save that total price. It wouldn't care. It wouldn't cause us any trouble. But we do want to save that total price in our main. So in our main, we're going to add in the code to say that whatever gets returned from our compute function should be saved in the total price variable. Now that means I'm going to need to declare that variable if we're going to use it in our main. And then I'm going to put in our parameters or our arguments for our output results call. For our output results, we wanted the price, the rate, and the total price. Now our output results function isn't built yet, but we can go ahead and test. And we should be able to test without canceling or anything now because we are supplying the right arguments for those parameters. So everything should be happy, maybe. Yes, sir?
In the output results one, it says price, rate, and sale price. Yeah.
Yeah.
You want us to put total price?
Yeah.
Okay.
So in notice, that's really good to notice those names do not have to be the same because we are, you know, different programmers. You might be in Asia, he might be in the Philippines working on this code. So you don't care what he calls it, he doesn't care what you call it. So as long as we know our data is correct. So let's run it. Okay, I got my enter the item name, the item. I'll make it $100, 10% discount. And then I see my message that I'm in the compute function and in the output results function. So everything is moving right along. Now our compute function just did calculations. So if we want to see any more output, we have to fix our output results function and then we'll have it all. Did it do? It looped again? Take control. I don't see it. Let's see it. Okay, share for us. Everybody will find it because it's early. So run it for us. That looks okay.
Yeah, but it was twice.
Where did it do it twice?
Right.
Oh, all of those. Oh, okay, I see. So where is that coming from? Those prompts.
Mine repeats after I ask them for discount.
Yeah, and then it goes back to automatic. Yeah.
So if you look down in your main, how many times are you calling the input data function? There's the first time where you're saving its output. What about that next line? Is it calling it again? Go down, the next line is calling it. And then that next line is calling it again. So just delete that. That was from when we changed it to save that data. Now run it and make sure you're not getting them twice. Yay, okay. Good, looks good. All right, release that thing. Is that what yours was?
Yeah, that's what.
Okay, cool. Okay, so now we want to do our output. In our output results function, we really don't need to declare any variables, I don't think, because we're just going to print out all of this stuff that we have. Our last time we ran it, we printed out quite a bit of information. Let's see if we can do all of that now because we only have our 3 parameters being passed to us. So first of all, we're going to say the item and then add our item. Oh, we don't have our item, so never mind. We are going to say the original price. And we're going to set our price to a string. And then I want to add a little bit more. I'm going to say discounted by, and we'll add our rate. We would like it to be a string also. And then it would be nice after that if we added that percent sign. And let me fix this so you can see it. So we're going to say the original price. Let's put a $sign at the end of that one. $50 discounted by 10%. How's that? That should look okay. And then we'll print the sale price is now we can't really output any other information here because we don't have those variables at our disposal here in our function. So if we wanted to output more information like the discount percent or the tax amount, things like that, we would have to add those as parameters so that we could get them to this method, this function. But now we should have some output. So try it if you're ready. See what you got. So I've got the original price, $55, discounted by 10%. The sale price is, I need to put a $sign on it. And of course, we could use the %D formatting characters that we could use with Python to do even more specific formatting of our output if we wanted to for our currency and things like that. So a lot of new stuff today. Let's set up and run this in the debugger. We've got this awesome PyCharm tool. Let's use it. What I want to do is set a breakpoint. Remember, that's just a place where my program's going to stop and let me control execution. I want to set a breakpoint right here at this welcome call. So I'm going to go over into that gray area and just click. And then instead of running the program, I'm going to use the debugger to debug the program. As soon as I start, then it's here. It's stopped executing right here at this line of code. It's ready to run it for me. It's showing me all my variables. All my variables have their default value right now. There's nothing in them. We haven't done anything with them at all. So now I'm ready to do my debugging session. Remember, if I do step into, I'm going to see all that Python system code. I don't really want to see their code. I want to only see mine. So I'm going to use the lighter blue that step into my code. And I should see the control transfer to my welcome function. There it is. So now the processor is executing my welcome function. If I step into that, I should see it print out my messages. There they go. And now that's the end of my welcome function. So control is going to return to my main to the next line of code after the call to the welcome. Now we're ready to call our input data function, and it has these return values. So I'm going to go ahead and step into that, and I should see my new variables get declared. Let's watch them show up here in our variables screen. Right now they don't exist, and notice right now our variables from our main don't exist because they're only available in the main. Now I'm going to step into this. There's my item variable. And now I've got my original price variable. And finally, my discount rate. Now I'm ready to prompt for the item name. It's over here on my console. I could do some sort of keyboard fancy thing, can't I? No, I can't. Ah, I went crazy. I broke it. Let me type it.
There's a keyboard button, not really long.
Thank you. Don't have to use that one, huh? Now I got something entered there. So now it's asking me for, or it's going to, if I step into, ask me for the original price. I'll type in the price here. And keep going. La, la, la. %40 discount, we'll have a big sale. Now, input data, of course, is the awkwardest thing, but that should be it for all I need for my input data. So now I'm to the return statement. If you guys mouse over those variable names, does it show you the values of those variables? You have to kind of give it a second, but notice how it'll pop up and show you what their values are. So if you don't have the variable window available, that's okay. You can still see them by mousing over them. Now, when I click step into, again, it should return out of my input function back to the main. So now if you mouse over your variables here, item, price, and rate, you should see values. And I can click back on my debugger tab and see those values. Now, if I want to see it execute my total price function, again, I can just step into, and we should see control transfer to our total price function. That's what the processor is running now. As I step into it, I'm going to declare our variables. If we look at our debugger screen, we'll see those show up as they get declared. Now they're available. We can use them. We're going to print out our message, do our calculations, and then finally return that total price variable to our main. Now we're ready to run our output results function. We'll see control transfer to it. It'll print out our messages. And finally, we return back to our main and be done. So the debugger can really help you visualize how that control is being transferred from one function to another in your program code so that you can actually see that happening. So you can be like, oh, okay, so my function is running. Use it a lot. I want to turn off this breakpoint, so I'm just going to click on that red spot again so that it doesn't keep stopping me. Lots of different things we can do with our functions. Let's update our Python quick reference. We probably have a lot of things to add to it. I'm going to have to go find it. I like it when it's right there on the list, you know. I've obviously been doing too much word stuff. So we haven't updated in a little while. We have our looping stuff, our while statement, our for statements. So we're not too far behind. Let's add now our def statement. So def function name, and then param1, param2, param3, etc. And then after our parameters are colon. So this defines or declares a function. Function must be declared before it can be called. What else? Our parameters. I'm going to put some things here like parameters are optional, but the parentheses are always required. So even if we don't have any parameters to list, we still have to have those, that open and close parenthesis. Now for our examples, if you want to put some examples in this third column, I could say def welcome for our welcome message. We could say def calculate and have our price rate. Now, when we're working with functions, we saw that we also need to be concerned with the return statement. The return statement has the return keyword followed by variable or data to return. So the return statement, return is the keyword. We can use a variable, a calculation, a true, false, if statement, all sorts of things can be returned. Now again, the code that we created, we had some examples. So we said return total price. That was one thing that we returned. We also saw that we could return a list. So item 1, item 2, item 3. Now to call a function, we just say the function name followed by the values we want to pass to those parameters. So this calls a function. Again, the parentheses are required. So even if we don't have any values to pass, we still have to have the open and close parentheses when we call a function. Let's do one more, and let's say that if we have variable equals function name, then variable will hold the return value. So some examples, we said total price equals calculate with the price and the rate. And then we also saw that we could do the tuple thing where we could say value 1, value 2 equals function returning multiples. And we could get all those values returned from our function. So our super important things, first of all, modular programming is good. As new programmers, you need to really push yourself to create functions, logical functions in your code. We've noticed, Markley and I have noticed that people are reluctant to create subprograms, submodules, because it's easier kind of to just have all of your code in one module. But you really need to stretch yourself with that and be trying to create code that is modular in that way. And that's what you're going to see in the real world. We don't have a lot of what's called spaghetti code. So if I look at the code that we created, I like it. I think each of our modules is an important logical function of our program. Our main has a few lines of code in it, and we want to start being careful. So if we see a function that's getting like 10, 15 lines of code in it, we want to look at that and see if maybe it's doing more than one logical thing. Maybe it should be broken into multiple functions. Another thing to consider is where we did our print stars. I'm going to click on that because I still have that tab open. Notice how when we did our print stars, how easy it was to change that from running once to running within a loop. We didn't have a whole bunch of code here that we had to get indented and make sure it was all right, because now we had all that code contained within that function. We were able to really easily throw it in a loop and run it over and over repeatedly. So that function gives us that capability, that it actually makes it easier to work with, even though at first it seems like it's a little difficult because we have to do that declaration and make sure our parameters are right and all that kind of overhead. But in the end, it's actually a lot better for us. we'll see that it's better for us. So the other one that we have 20 minutes. Let's open, if you can, and I'm going to open mine. In chapter 5, we did our car price calculator in Python. See if I've got it. Oh, are you dead? Is it empty? Mine's acting empty. Do you think I didn't save it? I don't have it. There it is. I was like, oh no, I just have 2 versions of it. So the one that actually has code in it is not chapter 5 car price calculator like it should be. It's just car price calculator. So check yours, you might have named it the same. Now what I'd like to do with this one is kind of just be thinking about it. So I don't want you to necessarily redo this one, but what I'd like to do is open Visio and think about how could you make a data flow diagram for this car price calculator. How would it work if we split it into different functions? And it should be pretty easy because if you remember doing the Raptor version of this thing that went on forever, it already had it set up as different modules, different functions. So let's find Visio. This week, you do have a Visio diagram to do as part of your assignment. Please just do it at school. Don't worry about trying to get Visio downloaded at home and installed because Microsoft has really changed the way the site works and the videos are not correct right now. And I'll get new ones out there for you, but you don't need to go through the trauma right now of trying to do that. So we have Visio installed here. If you just follow the instructions, it's not bad at all.
You just went on the website where you showed us 2 months ago, 3 months ago.
Yeah, but it's all different. So they've got a link there to a new site.
I just hit like the purchase gets free on that website. So I just hit purchase.
That's what I did too.
Yeah, but
And
it's
then
all
I
different
downloaded it,
now.
put in the code.
It's all different now. Yeah, they
For
changed
me,
it all.
just tell me to like burn it, like
To an
ISO file,
yeah.
and then you have to like burn it to somewhere else.
Yeah, now it's all different. But you're good if you already got it.
That's what it's saying.
We'll get the new instructions out there. But if you go out to that Imagine site right now and log in, you can still get your product keys, your old ones, but now it has a big link to their new site that they have set up. And so if you click on it, it's not too bad to try it. It's just a little different. So I just don't want you to have to fight with it right now. Unless your stress is really low and you want to find it, you can. All right, so we want to do this data flow diagram. I'm going to go with flowcharts here as far as templates to see if I could find something that would be a good template for that. I could start from scratch, but why? So for my data flow diagram, the only shape I really need is this rectangle. So a basic flowchart would probably do it. I'm going to look down and see if there's some sort of magic thing. Oh, this one's cool. That's probably a really fancy data flow diagram for if we wanted to show subprograms. So let's just pick our basic flowchart. That's going to be enough for us right now. I want a colored one. You don't have to have a colored one. It's up to you. Now that's one problem of using their fancy colored ones. Then you have to delete all the junk that it puts in your flowchart for you. I'll just select everything, delete it. So I have a nice clean piece of paper here, ready to draw my data flow diagram on. I'm going to start out with my main. So I'm going to use the process box and bring it up here to the top. I'm going to double click on it and say this is my main. Now you can zoom in, whatever you want to do. Now, before I go any further with my data flow diagram, I should really put a title and stuff on it because it's not going to mean much to others if it were to get printed out and not be identifiable. So I'm going to look up here at more shapes, and I want to look at Visio extras, and I just want Oh, like an annotation. I could do a title block. I'll do a title block. That'll be fancy. Now the title blocks, there are lots and lots of choices. Some of them are very involved and have to do with, you know, architectural requirements and things like that. I kind of just want a title block. I'll do title block small. I'm gonna, whoa, see, there's the small one. I'm gonna put that on my diagram. I'm gonna make it really small. Yeah, I don't like that. What do you think? It's icky. I'll just do a frame. I could have probably just done a text box.
There's one that's just called title. That's
Yeah.
really,
Where is it? Just
It's
with,
part of
just that one? Is that one good title? Oh yes, that's much better. Thank you. That's what I want. And we'll just say this is the car price calculator data flow diagram. I'll make my shape big enough to hold all those words. Now, if you notice, there are lots of revision things because those are really important when we're looking at diagrams like this. If I were to bring up a data flow diagram or a flow chart in the organization that I worked for, different companies have different standards. Some companies don't use them at all. Some companies require up-to-date flow charts just to show program-to-program relationships, not so much the individual program flow. And if they require that, they usually have some sort of administrative person that takes care of that for all of the programmers. So we would give that person the requirements and they would actually set it up in Visio. And then they would make sure that anytime there were updates, they used one of those revision blocks to add a new date. That way, if we see one, we know how new and up to date it is. If we're looking at a document that hasn't been revised in 10 years, and we know that that system gets changed all the time, then we know that this document we're looking at is probably obsolete and not any good. But if we look at it and we see that it was just revised, you know, a couple weeks ago, then it's probably up to date and something that we can depend on and help. So in our car price calculator, our main for this was going to do some information gathering. And if you remember, the first thing that we asked for, see if I can bring it up, was we have a welcome message. So let's add in a module for that. I'm going to go back to my basic flowchart shapes, find my process, and I'm going to put it down here, and I'm going to say, this is my welcome module. Now I want to connect these two. There are lots of lines that are available to you when you're using Visio. The connector tool that you can access up here is kind of handy because it lets you establish a connection between these two shapes so that if you move them around, the line will snap to and stay connected to them. It might not work very well for you for this data flow diagram though. For a data flow diagram, you might want to actually draw lines yourself. So work with Visio and kind of decide. I'm going to show you how the connector tool works. I'll go to the connector tool. Come on, you silly. And then when I click on my main box, I get that green box. That's what I'm looking for. That's a connection point. So now if I start drawing my line in that connection point, it's going to be connected to that shape. And I'm going to stop drawing it when I get the green box on my glue to point. Now that line is actually connected to both of those shapes. So if I move one of those shapes around, come on, shape. Oops, I need to go back to my pointer tool before trying to move things around. I can get rid of that. Move it, and you can see how it'll move the line around with it because it's connected. Now I've got to get rid of this weird line that I got there accidentally. Okay, so the next thing that our program did, so we don't like this all straight straight through code, sequential. We want to make it more modular. So the next module that we would have would be this info stuff, right? What's your name? What type of car do you want? And what's the base price? So let's call that our gather info module. So I'm going to put another process on here. Call it gather info or input, whichever you like. And then I want to use the connector tool and connect it to our main. And you'll see how Visio, at first might be nice to you and do things the way you like, and then it'll start just kind of taking control and making things hard for you. But I'm going to go back to my pointer tool now, and I want to move my gather info down just a little bit because I want to add something in to add in what I'm going to return. So let's see, I want to get I think a text box. And I'm going to put in the data that's going to get returned from gather info. My name, the car make, and the base price. Again, I'm going to click back on my pointer tool and kind of rearrange things in Visio so that I can get this set up the way I want. I think if I try to get too many lines and arrows, it gets kind of crazy. So I'm going to put something like returns and then name, car make, and base price. And you can try it. See how you can get it in a way that you like it. So our rules when we're looking at this data flow diagram are, we're using these rectangle characters to document each of our functions, our subprograms. And in text somehow, we're sending our input and supplying our return values as output. So maybe the word output would be better than returns. And you could come up with your own standard. You might even decide that you're going to make all of the output text boxes one color and the inputs a different color, and that could be meaningful to you. Now, when you're looking at this, what I want you to do is take these last few minutes, we don't even really quite have 10 minutes, and put these remaining modules into your data flow diagram and be thinking about what input and output you would need for each of them. Next week, we're going to have our unit exam, but on Tuesday, we'll have time to work more with our functions. So on Tuesday, first thing I'd like you to show, be prepared to show the rest of the class what you did for your data flow diagram. Now, it should be pretty obvious with our program here. We know we're going to need one to get the engine choice, right? So we should be pretty specific with our modules. So get that done, and we'll try to take a look at them real fast next time before we get started on other stuff. Questions about functions before we? That's great. I think that was really, we've got a lot done today.
When are we going to learn about map functions?
About what?
Map functions.
You don't get no nap. You know how that works. You know how.